1.8, absolute value equations and inequalities. So now we're going to start talking about absolute value. You're familiar with this, you've seen this before, this isn't a new concept to you. So the absolute value of A, and what the absolute value does is it finds the distance on the number line from this value to the origin. So essentially it's just removing a negative sign. But we have to realize with that means A can be either positive or negative, but the result is always going to be positive. Now, if we're dealing with that, if I were to make X inside there, the absolute value of X, then really we could say the absolute value of X is going to be the positive value, but X could be either positive or negative. So if I said the absolute value of X is equal to A, then X can either be A or negative A, right? Because it's removing the sign. So we're going to start into it. Let's look at what this means for solution sets, looking at both equations and inequalities. So if I have the absolute value of X is equal to A, then my solution set is going to be strictly negative A and A, because we're saying it's equal to that, so there's only two possibilities. X is A or X is negative A. It takes out the sign. If I add in inequalities, so if I say the absolute value of X is less than A, well, it could be less than A on either side of 0. So if you think of a number line, if I say within 5, so that's less than 5 away from 0 on the number line, that can start as low as -5 and go up to +5. So we can say that our interval is going to be from negative A to positive A, or in interval notation, we could write it as negative A to A. Notice that we are not including A as a possibility. We're within the range from negative A to A exclusive, because we do not have an equal sign here. If I take the absolute value of X is greater than A, now we're looking on both sides of the number line, positive or negative, and saying it's farther away than that amount. So therefore, we would say it's that A, actually not say that, we'll say X is less than negative A, or X is greater than A, or if we wrote it in interval notation, we would say from negative infinity to negative A, union A to infinity. Now I will note with these that these are strict inequalities. If they were not strict inequalities, if they included equals, then all that would change is that these would then include, don't include infinity, right? So adding the red there, that shows what would happen if it was not a strict inequality. But the same idea, if we're saying that the absolute value is less than some value, then we're going to be within that amount of the origin. If it's greater than some value, then we're going to have everything outside of that area of the origin. So let's put this to use, because notice this, like here, this gives us the effect that x can have two different values, because we have to assume it can either be positive or negative. So if we have the absolute value of 9 minus 4x is equal to 7, so we're at the equation, so 9 minus 4x, the absolute value of 9 minus 4x is equal to 7, then what we're really saying is that this positive or this negative, or basically that 9 minus 4x is either equal to 7 or it's equal to negative 7. So we're going to treat it as two separate equations. 9 minus 4x equal to negative 7. 9 minus 4x equal to positive 7. Because we know that either one of those will make this 7. Then we're just going to solve it the same way we would any other equation. Solve for x, so we're going to subtract 9 from both sides. Negative 4x is equal to negative 16. Divide both sides by negative 4, x is equal to 4. Over here, subtract 9 from both sides. Negative 4x is equal to negative 2. Divide both sides by negative 4, x is equal to 1/2. And therefore the solution to this absolute value equation would be x equal to 1/2 and 4. Or in set notation, let's try to make that actually look like a bracket. 1/2, 4, and the other bracket. So those are our solutions to that. I want to point out something else before we go on to another solution. Well, what happens if I have the absolute value of A is equal to the absolute value of B? Well, we know that if this was just B without the absolute value sign there, we'd know that A was either equal to B or negative B. And if this didn't have the absolute value, then we know that B would be either A or negative A. So since we have absolute value on both sides, really, it doesn't change anything. A is either the same as B, or A is the negation of B. And think about it, it really doesn't matter, because if I were to multiply both sides of this by negative 1, then I'd have negative A is equal to B. So I'd have B is equal to A, or B is equal to negative A. So having the absolute value on both sides doesn't really change the work that we're going to do. So let's take a look at another problem. The absolute value of 3x plus 2 is equal to the absolute value of x minus 5. Sure is handy that I just mentioned how that works. So basically with this, I can set it up the exact same way. 3x plus 2 is equal to x minus 5. Or I can say 3x plus 2 is equal to negative x minus 5. So I'm going to go through and solve for x. Bring the x's onto the same side, so subtract x from both sides, and I get 2x. I'm going to subtract 2 from each side. So negative 5 minus 2 gives us negative 7. Divide both sides by 2. X is equal to negative 7 halves. which I can leave it like that, or I could call it negative 3.5. I'm going to leave it as a fraction just because I can. Here I'm going to distribute through the negative. 3x plus 2 is equal to negative x plus 5. Very important that you're careful about the fact that you have to put parentheses in here. Very easy to go, oh, it's got to be negative this into a negative x minus 5 without the parentheses, and then you've just changed the expression on that side. Now I'm going to get the x's together and the constants together, so I'm going to add x to both sides. That gives me 4x. I'm going to subtract 2 from both sides is equal to 3. Divide both sides by 4. X is equal to 3/4. And now we have x is equal to negative 7/2 and 3/4. And that's our solution to our equation. So dealing with absolute value equations, really not much different than what we've done in the past. The only thing is you have to realize there are going to be two possibilities. This is either equal to what's on the other side of the equation or the negation of whatever's on the other side of the equation. So let's move on and look at inequalities. Well, how is an inequality going to affect us? Well, we're still going to deal with these different possibilities. Remember, we had the absolute value of x less than some value. I'm just going to use b right now. I probably used a before. Doesn't matter. But the absolute value of x less than b, that gave us an interval from negative b to b, exclusive. The other possibility was the absolute value of x was greater than b, so that gave us two intervals from negative infinity to negative b, and from b to positive infinity. So we'll have to work with those. If you're dealing with less than, then you're going to turn this into a three-part inequality. If you remember when we were dealing with inequalities, three-part inequality, because it's going to be arranged, x is going to be somewhere between the lower end, negative b, the upper end, and positive b. Whereas if you're dealing with greater than, you're going to have to treat it as two different examples, just like we did with the equations, that you do one where you're dealing with less than, that it's less than negative b, the other that it's greater than positive b, because it is impossible to have a value that is less than some negative number, yet greater than some positive number. So they can't both happen at the same time, so we're going to have to treat it as two separate inequalities, whereas with this, we can easily have a value that's in between two other values. So let's try an example. Get this out of the way and take a look. The absolute value of 4x minus 6 is less than 10. In this case, we are looking at something where it's less than, so that means it's going to be between negative 10 and positive 10. It's not going to include negative 10 or positive 10 because it does not have equals. So we're going to write it as a three-part inequality. Negative 10 less than 4x minus 6 less than positive 10. And then once we've got that, we've done this before. This isn't too bad. We're just going to, whatever we do to any of these parts, we've got to do it to all three. We're trying to get x by itself. Now, I may not have mentioned this past. It should have been common sense, but in case it confused you, if you've got a three-part inequality, you want to keep the variable in the center. Don't try sending the variable out to the sides. You want to get the variable by itself in the center. If you try moving it out to the sides, you're going to have it in two spots, and you don't want that. You want it in one spot, it's got to stay in the center. So we're going to isolate this x, so we're going to add 6 to each part of the inequality. Negative 10 plus 6 is negative 4. 4x. 10 plus 6 is 16. We're now going to divide each part by 4, which gives us -1 less than x less than 4. And so we now have, that's written as a 3-part inequality, or I can write that as -1 to 4 in interval notation. So that really wasn't bad. We just have to remember that this can be either positive or negative of that. And we just follow the same steps that we've done. So it's getting from here to here is the only part we really have to think about what's happening. And then we just treat it like we have all of our other inequalities. Let's do another example. The absolute value of 5 minus 8x plus 6 is greater than or equal to 14. Whoa, well that got a little different, didn't it? The absolute value of 5 minus 8x plus 6 is greater than or equal to 14. Well, there's a few things we should take note of here. First of all, equal, so we do have equality involved, so those endpoints will count. Greater than, which means we're going to split it into the 2 parts, right? We're looking for it to be more than 14 away. The other thing that we have to look at is this plus 6. This plus 6 is on this side, but when we're dealing with absolute value inequalities, we want the absolute value to be by itself. It's kind of like we wanted when we were dealing with rational expressions. Or rational inequalities and such, we wanted a single rational expression on the one side. We want just an absolute value. Or if you look at when we went over radicals and how to deal with radicals, you got it so that you had a single radical on one side, solved that, and then went and did it again if you had another radical that you had to work with. So we have our absolute value here, we want to get it by itself. So the first thing we're going to do is say the absolute value of 5 minus 8x is greater than or equal to, we're going to subtract 6 from both sides of this. So 14 minus 6 is 8. Now we're down to a standard one, but remember, we have to treat it as 2 because we're looking at the outside. So treat it as 2 different ones, so we're either saying that 5 minus 8x is less than or equal to -8, so it's that side of things, or 5 minus 8x is greater than or equal to +8. So we've got these 2 inequalities to deal with. Now that we've got it to that point, we're just going to go through and solve for x. So the first thing we need to do is we're trying to get x by itself, so we're going to subtract 5 from both sides. So -8x less than or equal to, if I subtract 5, -8 minus 5 is -13. And now I need to divide both sides by -8. Remember, when you multiply or divide by a negative number when you have an inequality, it flips the inequality. So divide both sides by -8, I get x that becomes greater than or equal to, and I have -13 divided by -8, or 13/8. And then if we come over here, we do the same thing, subtract 5 from both sides, -8x greater than or equal to 3, divide both sides by -8, which means we're going to flip the inequality, so x is less than or equal to -3/8. So if you notice, we now have x less than or equal to -3/8, so from -3/8 over, and we have x greater than 13/8. So putting this in interval notation, and remember it includes equality, equals is in there. So we're from negative infinity to negative 3/8 inclusive, union 13/8 inclusive, to positive infinity. So we just broke it down into the pieces. If you're dealing with greater than, you're going to break it into two pieces because you're looking at the outsides. You're saying everything but what's in that range. If you're dealing with less than, you're dealing with everything in the range. So you can do it as a three-part inequality. And there we go. Well, let's take a look at what might be considered some special cases. And I know sometimes when we're doing math, we all feel a little special. So let's take a look at these. The absolute value of 7x plus 28 is equal to 0. Okay, well remember that this can be equal to that value or the negation of that value. So simply put, in this case, this has to be equal to 0. So 7x plus 28 is equal to 0, and we just solve it. Subtract 28 from both sides, 7x is equal to negative 28, divide both sides by 7, x is equal to negative 4, and we're done. Note that when this absolute value expression is equal to 0, there is only one solution. When it is anything but 0, we had two solutions. But when it's equal to 0, there's only one possible solution to it. So there we go, and we can put it in a set as negative 4. Just having a really hard time with those squiggles today. Okay, so negative 4. So that's one special case. When the absolute value is set equal to 0. Another special case is shown right here. So I have the absolute value of 6x minus 9 is greater than negative 2. Now you may look at that and go, Mr. Davis, what's so special about that? What are we going to do? Well, that's obviously, if we have the absolute value here, and we have that on the other side, you already told us that we set this equal to that, and we set it equal to the negation of that. Yes, that's what I said. What makes this a special case is the property of absolute value. If you take the absolute value of any number, you will always come out with a non-negative result. If you take the absolute value of anything, you're going to come out with a non-negative result because it eliminates that negative sign. You're going to get 0 or something positive. So when you have a case like this where you're saying the absolute value of this is greater than negative 2, negative 2 is negative. So we take the absolute value of anything, it's going to be greater than negative 2. Therefore, all real numbers. All real numbers. Negative infinity to infinity. It doesn't matter what value I plug in here, because I'm taking the absolute value of this, it's always going to be greater than negative 2. So I could give you a really horrible looking expression inside the absolute value. And if I ask, when is it greater than -2 or greater than a negative number, the answer is always. Because absolute value will never give me a negative value. So it's always greater than that. So that's why that's a special case, and we want to recognize that special case, because otherwise you're going to go through work and you're going to solve this, and you're going to give me a range, or actually with this greater than, you're going to give me two intervals and say, oh, it's either less than this or it's greater than this, and that's wrong. So be aware of this special case. Absolute value is always going to be 0 or greater. The final special case I want to show you, absolute value of 2 minus 5x less than or equal to -5. Okay, again, we know it's less than, so therefore you'd be looking for the interval from b to -b or from -b to b, right? So what makes this a special case? Well, we have a negative number over here, and it's asking me when the absolute value is going to be less than that negative number. What did we just say with the previous special case? Absolute value is always going to yield 0 or a positive, right? It's going to give you a non-negative number. So when is it going to give you a value that's less than some negative number? Never. There is no value that you can plug in for x that'll make this absolute value less than -5, because absolute value by definition will not give you a negative value. So that's our other special case. So keep those in mind, because as you work on these, you may see something like this, and that'll save you a lot of work. You should be able to look at that and immediately say, there's no solution, because absolute value will never be negative. The previous one you should look at immediately and say, there's no solution, the solution is all real numbers, because it's always going to be non-negative. Otherwise, you're going to do work to show how it comes out, and it's not going to be correct. So keep in mind the properties of absolute value. Now what I'd like to do is I'd like to kind of look at application of this, and specifically recognize that we're talking about distances. And so I'm going to look at it as, well, what if we have a statement such as this? M is no more than n units from 3. So I want to say, how do I write this as an inequality? And using absolute value. M is no more than 9 units from 3. M is no more than 9 units from 3. So it can't be more than 9. And we're talking M must be no more than n units. It can be less than or it can be equal to 9 units, but no more than from 3. So we're talking about the absolute value of m minus 3 is less than or equal to n. M must be no more than 9 units from 3. So the distance from m to 3, distance is found just by taking the difference, and then absolute value gets rid of a negative sign, so it doesn't matter the direction, must be less than or equal to 9. T is within 0.02 units of 5.8. T is within 0.02 units of 5.8. Within, that means less than that value. It does not include equality for that. But if it's within 5 points, within 3 feet, right? Within 3 feet means it's 3 feet to the one side or 3 feet to the other side. Within, but does not include. Now I know when we speak in English, many times when we say within, we're talking about, we'll include that within 3 feet. If it's 3 feet or less, I'm okay. But if you really think about it, I am right now inside a room, or I am within this room. My boundaries are these walls. I have to be wholly inside of these walls. I cannot be at the wall, meaning if I was at the wall, I'd be literally in the wall. So I can't be equal to that, I have to be inside of it. So that was T is within 0.02 units of 5.8. So I'm saying the distance from T to 5.8 must be less than 0.02 units. So that's dealing with distances. This is within that of that. I want to do one more example dealing with tolerances. Tolerances are where they give you a range. Let's say you're dealing with mechanical things. Let's say you're dealing with screws and such, or you're drilling a hole so that you can put a machine screw through it. Well, you'll want the hole to be a certain diameter, but they will also give a tolerance. So it must be drilled a 1/2 inch diameter plus or minus 1/100th of an inch, or plus or minus 1/8 of an inch, depending how much play they can have in it. So these are tolerances, so we have a value plus or minus something else. And that's giving us an inequality, isn't it? We're saying we're going to have a range. It's from with here to here. The center point is whatever we're looking for, and then we're allowing it to be a little bit more or a little bit less. Okay, so suppose y equal to 5x minus 2, and we want y to be within 0.001 units of 6. So y is equal to 5x minus 2, and we want y to be within 0.001 units of 6. For what values of x will this be true? So we want to know what values of x will allow y to be within 0.01 units of 6. Wow, I have to think about this just a moment and see what we're saying. So we want it to be within 0.01. Okay, so to me, less than 0.001, within 0.001 units. We want to be y within that of 6. So the distance from y to 6 has to be less than 0.001. So that means the absolute value of y and 6 must be less than 0.001. Just putting my paper out of my hand. Well, what is y? We're looking for what x values will allow this to happen. So we know y must be within 0.001 units of 6. Well, y is 5x minus 2, so I can rewrite this as 5x minus 2 minus 6. I'm going to put that in parentheses just to clarify that. Less than 0.001. And now we can solve it's less than, which means we're going to have that three-part inequality, so we're going to go from negative 0.001 less than 5x minus 2 minus 6 less than 0.001. We can combine these together, so we might as well take care of that now. Negative 0.001 less than 5x minus 8 less than 0.001. Trying to get x by itself, so I'm going to add 8 to both sides. 8 minus 0.001 gives us 7.999 less than 5x less than 8 plus 0.001 gives me 8.001. And then a final step here, I need to divide both sides, all the sides by 5. Let me grab my calculator because that's going to need to be done there. So 7.999 divided by 5 gives us 1.5998 less than x less than, and then 8.001 divided by 5. Now looking at that, we could take an estimate on there and say it's going to be on the other side, but let's do this. Divided by 5 gives us, so I would think that would be 1.6002. Oops, hit an extra button in there. 8.001 divided by 5 equals 1.6002. So x from 1.5998 to 1.6002 exclusive. So I can write it as that, or I can write it 1.5998, 1.6002 in interval notation. So taking it from a word problem, something we need to figure out. And yes, there are numerous reasons why we may need to do a calculation like this. This may be an electrical component that we need to determine if we want the full system to have a certain tolerance, because this is what this is. That's the tolerance of the full system. I need the result of the system to be within this amount of some value. So I'm looking for an output of 6 within 0.001. Well, what's going to affect that? This component will. So what tolerance can I have in this component? So that's where you, if you're selecting resistors or capacitors and inductors for your circuitry, you work your way back and say, well, I don't want any more slop in my circuit than a certain amount. So then you can work back to that component and say, well, how much slop can I have in this component before I get too much slop in the circuit? And that's why you end up buying different tolerance resistors. You may buy one that's got a tolerance of plus or minus 20%, which is huge. Plus or minus 10%, plus or minus 1%, plus or minus 0.01%. So depending how much tolerance you can deal with, then you select the correct component to give you the tolerance that you need overall. So that finishes up absolute value equations and inequalities.